All right, y'all. Today we're going to be talking through part one of rational operations. We're going to talk multiplying and dividing today, and then tomorrow, or next class, we're going to talk about adding and subtracting these rational expressions. So today we're going to focus on multiplying and dividing, and we're going to look at this first example. So we're going to multiply 5x squared over 3x squared minus 75 times 3x minus 15 over 4x squared. And one of the key things I want you to see is that by simplifying first. And the reason why we're going to simplify before we start multiplying is kind of twofold. For one, it's actually going to make what we multiply just a little bit easier. And it's going to make sure we don't actually end up missing any x values. So I want to multiply 5x squared over 3x squared minus 75 times 3x minus 15. I want to see if I can simplify anything before I start multiplying. So 5x squared, it's a monomial, it's just a little term. There's not really anything I can do. 3x squared minus 75, though, I can actually simplify that to be, let's start out by saying 5x squared over, and then on the bottom, 3x squared and minus 75, I can actually take a greatest common factor of 3 out of both of those. Which would leave me with x squared minus 25 on the inside of the parentheses. Looking at my other set of rationals, I have 3x minus 15 over 4x squared. So same thing, that 3x and that minus 15, I can actually simplify to be taking the 3 out as a GCF, and then I'd just be left with x minus 5. And on the bottom, still that 4x squared. Okay. And then there's actually one other thing I can do to kind of simplify this, make it a little bit easier to see. If you'll notice that x squared minus 25, I can actually factor that out into individual factors. So I can split that up into x plus 5 and x minus 5. So this would become 5x squared over 3 times x plus 5 times x minus 5 times 3 times x minus 5 over 4x squared. So I've done all my simplifying steps, and then with multiplying rationals, it's simple. I just multiply across. This is not cross multiplication. Notice there's not an equal sign in the middle. I'm just multiplying two. So I multiply everything on the top and everything on the bottom. Because I'm not separated by any addition or subtraction, now that I've kind of simplified, I can just multiply all the way across. So 5x squared times 3 is going to be equal to 15x squared. And then times x minus 5. And then on the bottom, 3x plus 5 times x minus 5 times 4x squared. I can multiply that 3 and 4x squared, which would become 12x squared. And on the bottom, I still have x plus 5 and x minus 5. All right. Now what I want to do last is I now want to see if I can cancel and simplify anything out. So first things first, I see that x minus 5 and x minus 5. So just like we've talked about before with our wholes, if I have the same factor in the top or the bottom, it cancels out. So x minus 5 and x minus 5 are going to cancel out. I don't have anything to match my x plus 5, but I can cancel out x squared and x squared. And then last but not least, 15 over 12, both of those numbers are divisible by 3. So I could reduce that to 5 over 4. So this would become a new simplified rational function of 5 over 4 times x plus 5. And so that's now my new simplified function. The reason we're kind of talking about this is because you notice that kind of looks like a rational function that we'd actually use to graph, or we might possibly use to solve a function or something like that. The last thing we want to talk about, if you'll notice in our question, is we want to list the restrictions. We want to think of what have we talked about so far with rational functions, things like discontinuities, like asymptotes, like wholes, that might cause restrictions on the domain or the range of our function. And if you can see, not only do we have some x's that canceled out, we also still have an x in the denominator. So our x's that canceled out, I have x minus 5. I can set that equal to 0, and that would give me x is equal to 5 as a restriction. I have my x squared that canceled out, so I can set that equal to 0. Square rooting both sides, we would get x is equal to 0. because the square root of 0 is just 0. So x is equal to 0 is a restriction. And then last but not least, we still have that x plus 5 in the bottom of our denominator, which, just like we talked about rational functions, that causes vertical asymptotes, which would be an issue. So setting x plus 5 equal to 0, we would get x is equal to negative 5. So our restrictions for our domain, our restrictions on our expression would be that x cannot equal 0 or positive or negative 5. And that's pretty much it, y'all. So when we're working out these multiplying rational functions, we're going to simplify in any way that we can first by factoring, taking GCFs, anything to try and make it a simpler problem. Then we're going to multiply across. We're going to see what cancels out, and anything that cancels out or anything that we still have in the denominator of our rational function is going to end up becoming those restrictions on our expression. So let's look at example 2. Let's do this first one. 3ab squared over 4c times 2c squared over 27ab. So with this one, everything's a monomial technically because everything's being multiplied. So I don't really have to do any restrictions right off the bat, okay? Or any simplifying, right off the bat. So instead, I'm just going to start by multiplying across. So multiplying across, 3 times 2 would be 6. So this would be equal to 6a b squared c squared, because I'm just multiplying all of my variables. And then on the bottom, 4 times 27. I'm going to go ahead and leave that as 4 times 27 for right now. And you'll see why here in a second. Okay, and then on the bottom, C, A, and B. So we can just write that as A, B, C to keep it consistent with the multiplying pattern we have on top. So now let's look what we can cancel. So we have an A and an A in the top and the bottom. We have a B and a B squared. So we're going to cancel one B in the bottom, and that B squared, we'll get rid of the squared in the top. And then C and C squared, so we'll do the same thing, getting rid of the squared and the C in the bottom. Then let's look at those numbers. We have 6, 4, and 27. So I believe first things first, we can cancel out a 2 out of both of these numbers. So that would leave me with 2 down here in the bottom. And up top, that would leave me with 3. Okay. And then I also have 3 over 27, which I could reduce this down to 1 because it's divisible by 3. And I could reduce my 27 down to 9. So now all I have left in the top is a 1. All I have left on the bottom is a 2 and a 9. So simplifying my rational function down, that would become 1 times b times c, which is just b times c, all over on the bottom 2 times 9, which would be 18, because all of my other variables canceled out on the bottom. And that's all there is to it. So sometimes you don't even have to multiply those coefficients all the way through. You can just kind of multiply across the top and across the bottom. Okay. I'm going to skip B and C because B and C are very similar to the first example that we already did. And I'm going to go over D with you and then let you, oh, never mind. Sorry, never mind. Let's go ahead and just do B, and then I'll let you do C and D on your own. Okay, so looking at B, we have 3x over 5x minus 15 times x minus 3 times 9x squared. 3x is a monomial. X minus 3 is a binomial, but there's nothing GCF-wise that I could take out. 9x squared is a monomial. Nothing I can really do there. 5x minus 15, though, I can take a GCF of 5 out. So my new rational expression would be 3x over 5 times x minus 3 times x minus 3 over 9x squared. And as I've been doing, I'm going to multiply atop the cross and atop the bottom. So 3x times x minus 3 would give me 3x parentheses x minus 3. Then on the bottom, we would get 5 times 9x squared. So I'm going to go ahead and do the same thing I did last time. I'm not going to multiply the 5 and the 9. So 5 times 9x squared, and then times x minus 3. So just like last time as well, you can see I have an x minus 3 and x minus 3, so those are going to cancel out right away. Then I have an x and an x squared, so I'm going to cancel out an x in the top and an x in the bottom. And then I have 3 over 9, which that would reduce down. Both are divisible by 3 to 1 on the top and 3 down in the bottom. And I can go and simplify my expression from here. So 1 times everything else canceled out on top. And remember, when we're canceling things out, it doesn't cancel out to 0. It cancels out to 1. So on the top, all I have left is 1. And on the bottom, I have 5 times 3 times x. So that would be 15x. And that's all I got, y'all. Now, before we move on from these two problems, there's one piece we didn't do, and that's talk about the restrictions. Remember, restrictions come from anything that cancels out or any variables that are left in the domain. So let's look at B first. So B, we had x minus 3 cancel out, which would give us a restriction of x could not equal positive 3. Remember, I get that by setting whatever canceled out equal to 0. And then I had an x canceled out, so also x cannot equal 0. And then even though I still have that 15x in the bottom, if I set 15x equal to 0, I would also get x equals 0. So I cancel out an x, but I also have an x left over. So regardless, x still can't equal 0. It would still be an issue in this problem. Okay, so x cannot equal 3 and x cannot equal 0. My restrictions on B. Over on A, looking at what we canceled out an A, we canceled out a B, and we canceled out a C. So for all of those, our restrictions are going to be, if I plugged in 0 for any of them, that would be an issue. So A cannot equal 0, B cannot equal 0, and C cannot equal 0. All right, y'all, so I'm going to go ahead and let you try C and D on your own. Okay, only thing to look out for D, there's 2 of them, so simplify it all, multiply all together, and then see what all cancels. You'll still have one single fraction when you're done. So go ahead and pause the video and try C and D on your own. All right, y'all, so let's look at C and D real quick. So on C, we can simplify that to x plus 5 over x minus 3x minus 1 times x minus 3 over 4 times x plus 5. We can, once we multiply across, we see that x plus 5 cancels out, x minus 3 cancels out. So we're left with 1 over 4 times x minus 1. And then all we have left in the bottom is that x minus 1, that 4. We have the x plus 5 and x minus 3 that cancel out. So that gives us that x cannot equal 3 or negative 5. And then the x minus 1 that's still left over would give us that x cannot equal 1. So wholes and vertical asymptotes, those are the big issues that we're seeing with these rational functions. Moving on over the D. D is kind of messy, but you just got to take it piece by piece. So we can split that into 7 times x minus 1 over 3x cubed. X plus 5 over, factoring out a 9, we'd get 9 times x squared minus 1, and that x squared minus 1 can become x plus 1 times x minus 1. And then our very last one, x squared minus 5x minus 6, factors into x minus 6 and x plus 1, and x cubed plus 6x squared plus 5x, we can take out an x, and then that quadratic that's left over factors into x plus 1 and x plus 5. So a big old mess, but I just multiply everything across. I get 7 times x minus 1 times x plus 5 times x minus 6 times x plus 1 on the top, on the bottom, 3x cubed times 9x times x plus 1 times x minus 1 times x plus 1 times x plus 5. And then I start going on that canceling spree, x minus 1, x minus 1, x plus 5, x plus 5, x plus 1, x plus 1. And I'm left with 7 times x minus 6 on the top over 27 x to the 4th times x plus 1. And if we notice, I don't have an extra x to cancel out. 7 and 27, 7's prime, and 27's not divisible by 7. So that's as simple as that gets. Looking at what canceled out, we canceled out x minus 1, so that's 1. X plus 5, so that's negative 5. X plus 1, which is also negative 1. So positive and negative 1 and negative 5. And then we still have that x to the 4th. So that's going to give us our 0. Now, x minus 6 is still on the top, but remember, numerators does not cause a discontinuity. Like if I plugged 6 into that problem right now, 6 minus 6 would give me 0. I would have the whole rational function equal 0, but that's okay. 0 is still a number. I just don't want to have any discontinuities, any divide by 0, something like that. All right. Very last thing we're going to do is we're going to do division with rational functions. And division with rational functions actually isn't any more difficult than multiplication with rational functions. You just have to do one extra step first. Okay, and if you remember, there's something special we have to do anytime we divide fractions in mathematics, and that's dividing by a fraction is the same as multiplying by the reciprocal of that fraction. The reciprocal of the fraction is just the same fraction, but with the numerator and denominator switched. A nice, easy way to remember it is keep, change, flip. You keep the original fraction the same. You change the sign from division to multiplication, and you flip that last fraction to be the upside down version of what it is right now. So this would become 9ab squared over 4c times, instead of division, and then reciprocal, so 5ab 18c squared. And then from there, y'all, like I said, it's the exact same thing. So I multiply across, I multiply down below. I'm not going to multiply any numbers yet because I think I'm going to get them to simplify here in a little bit. So this becomes 9 times 5a squared b cubed over 4c times 18c squared. So 4 times 18c cubed. And let's see if I can reduce anything. So 9 and 18, both divisible by 9, so that would become 1. That would become 2. Then 4, 2, and 5. I'm not going to get 4 and 2 would make 8, 5. Neither of those are divisible by the same thing, so I can go ahead and simplify from there. I don't actually have any variables. I have a squared b cubed in the top, but then I only have c cubed down the bottom, so those aren't going to cancel out at all. So my final answer would be 5 a squared b cubed 4c cubed. And then the only restriction I'm going to have is that c down there in the bottom, I can't plug in 0 for it, so c cannot equal 0. And then we're good to go. All right, y'all. I know that was only one example, but like I said, division is just like multiplication. It just adds that one extra step that you change the sign from division to multiplication and you take the reciprocal of the second function. So I want y'all to go ahead and practice B, C, and D here on your own. So pause the video for a second and then I'll go over them. All right, y'all, let's talk about these really quickly. So let's look at B first. So B is relatively straightforward. 7x squared over, factoring out the 3, we get 3 times x squared minus 9. That factors into x plus 3x minus 3. Then becomes multiplication, becomes the reciprocal. So 3 times x minus 3 on top over 4x squared. Multiplying across, we get x minus 3's to cancel out. We get 3's to cancel out. We get x squared to cancel out. So 7 over 4 times x plus 3. And then the only things that don't work out, positive or negative 3, and then our 0 from things that cancel out and things that we still have left over in the denominator. So looking over at C, we have 3x squared plus 15x over x squared minus 3x minus 40. That can factor out into 3x times x plus 5 over x minus 8 times x plus 5. Okay, and then instead of division, it becomes multiplication, and I take the reciprocal of 5x squared over x squared minus 64, which does factor out into x plus 8, x minus 8, and then 5x squared stays the same. Multiplying everything across, I get an x and an x to cancel out, x plus 5, x plus 5, x minus 8, x minus 8, giving us that simplified fraction of 3 times x plus 8 over 5x. X cannot equal 0, cannot equal negative 5, and cannot equal 8. And then last but not least, y'all, we got this messy one here. We have division, then we have multiplication. But remember, we follow PEMDAS, so we're going to deal with the division first, and then we're going to do the multiplication. So 4x over x squared y squared minus xy, I can factor an x and a y out of both. So that becomes 4x over xy times xy minus 1. X squared minus 4 factors into x plus 2 and x minus 2. 3x squared plus 19x minus 14 factors into 3x minus 2 and x plus 7. And then I'm going to reciprocal that. So it becomes times 3x minus 2 over x plus 7 over x plus 2, x minus 2. And then last but not least, xy over x minus 2. Can't do anything to that, so it stays exactly the same. And even though the division and the middle fraction change, the last one, it's just still being multiplied, so it's going to stay exactly the same. So then multiplying across, the only thing we actually see that cancels out is that x times y term. So canceling out x times y, we get 4x times 3x minus 2 times x plus 7 over xy minus 1 times x plus 2 times x minus 2 times x minus 2. And then the only things that we have, our x and our y are going to give us that x can't be 0 and y can't be 0. We have an x minus 2 and an x plus 2, so that's going to give us that x cannot equal positive or negative 2. And then that xy minus 1, solving that one out, okay, we do actually get xy minus 1 is equal to 0. Moving the 1 over, we get x times y is equal to 1. And then if we divided over x or divided over y, we'd get that x can't equal 1 over y, and that y can't equal 1 over x, which essentially means like if x was 1/2 and y was 2, 1/2 times 2 would be 1, and then 1 minus 1 would be 0, which would be no good. So that's that little extra piece that we have here in D. All right, y'all, and that is the first part of our rational operations notes. So you should be able to now go ahead and do that first piece of the homework. So go ahead and complete that, and then I'll see you for next time.